Okay, we're going to go through the papers that you were given just before the holidays as mock preparation. I haven't got any notes, so forgive me if I just freestyle and ramble a bit. Here we go. And obviously there's some questions in here that we've not covered yet, so I will skirt over those. Right, diving straight in. Work out the mean number of children in these 25 families. Always read a question carefully. Sometimes these papers don't ask for the mean number, they ask for the total number of children. So that would be a step back from calculating the mean. So here we go. We've got a frequency table. So the number of children in a family with 1, there's 4 families. Then we've got 9 families with 2 in, 8 families with 3 in, no families with 4 in, and 4 families with 5 in. Totaling that up, that comes to 66. Now to find the mean, which I'm calling x bar, standard notation, 66 divided by 25, because there's 25 families. Don't divide by the number of rows. The number of rows is totally irrelevant to the calculation. 66 divided by the 25 gives me 2.64. No necessity to round that up. If you're going to round, at least write the calculator value first, and then whoever's marking it can choose to take the actual value from your calculator or the rounded one that you've decided to put in. Expanding, 1 mark for this, so you've got to get it correct. 4 lots of C, take away 12. Remember, everything in the bracket needs multiplying by the number outside. Similarly here, d lots of d squared becomes d cubed, d lots of 4 becomes 4d. The reverse here, what do they have in common? They have an x in common, and then we get 3 take away 2x inside the bracket. Usually 1 mark for the factor outside, 1 mark for both terms inside the bracket. ABC, isosceles triangle, so that means straight away that that's 70 degrees. BA and BC are parallel, so that means x down here is the same as x up here. This is just me thinking out loud. Find the value for x and give a reason for each step in your working. Right, well we've got a triangle, so x is going to equal 180 take away 2 lots of 70. 180 take away 140 angle 40 degrees. What reason have we used? Well, we've used the fact that ABC equals x because of alternate angles, and we've got that BAC equals 70 because it's isosceles. And we've got also angle sum of a triangle. So those are the reasons. Remember, reasons are not working out. Working out is needed, but if it wants reasons, we're looking for you understanding the properties. And don't put z angles, alternate angles. Question 4. Doesn't crop up a lot that you get marks for the units, but in this case we do. Find the area of the pond, so we know straight away for 1 easy mark that this is going to be meters squared. It's the area we want. Read it carefully, and so it's pi times radius squared. It's a formula that's given, so there's no excuse for getting this bit wrong. Pi times 8.9 squared. Dig it out on my calculator. Now my calculator is going to give 248.84555541. It does say write down all the figures on your calculator display. They're usually, because of different calculators, going to look for probably 3 decimal places at least. Now to 2 significant figures. Is it nearer to 250 or 240? It's clearly nearer to 250. Remember, significant figures don't make things in the tens column become units, and they don't make hundreds become tenths or units. Remember your place value. Show that's. Show that's with fractions. It's never going to be a winning solution to turn these into decimals. It's a sort of question to test if you know your methods to do with working with fractions. So 6/7 divided by 4/1 is the same as 6/7 multiplied by the reciprocal of 4, which is 1/4. I can cancel at this stage. 2's go into that twice. 2's go into that 3 times. That gives me 3/14 straight away, and it's convincing. Decimals are never a convincing way of doing these sort of questions. 3 2/5. Take away 1 2/3. First thing I'm going to do is make them top heavy. So that's 17/5. Take away 5/3. I then need to turn them into fractions with the same denominator. The denominator I'm looking for is 15ths. So I need to treble the top one, making 51. I need to multiply this one by 5, making 25/15. I'm then at a position where I can do that, and I get 26/15. That's what they're going to be looking for, some sort of top heavy fraction, not just 1 11/15 popping out of thin air. Solving. 7x add 3 equals 2x take away 4. I need to collect my x terms together, so I'm going to subtract 2x from each side. That makes 5x add 3 equals -4. And then I'm going to subtract 3 from each side. Gives me 5x equals -7. I'm then going to divide each side by 5. So x equals -7/5, which equals -1, and 2/5, which also equals -1.4. Part B. As a general rule, equations with fractions, your first step is to try and get rid of the fractions. So if I scaled the whole equation up by 3, or cross multiply if that's what you want to think of it as, then I'm going to get 16 minus 5y equals 6. I'm just going to shift it round. You could just subtract 16 from each side. That's perfectly acceptable as well, so long as you working with directed numbers doesn't cause you a problem. Subtract 6 from each side. 10 equals 5y. Divide both sides by 5 leads to y equal to 2. Check it to see. 16 take away 10 is 6. 6 divided by 3 is 2. Set questions, when it asks you to describe or interpret, it's not just asking you for the definition. So in this case, it's not saying what does A intersect B mean, it means what's in both. It means interpret it in the context of this question. So set A is Mr. Smith's clothes, set B is the hats. So describing the member of the set A intersect B is Mr. Smith's hats. Alright, the hats that are Mr. Smith's. Put it in English, Mr. Smith's hats. How many members has the set A intersect C? Mr. Smith's clothes, Mrs. Kosh's hats. How many members? Well, 0. Use a letter or symbol from the box to make each of the following a true statement. B union C. Well, Mrs. Kosh's hats is a subset, isn't it? So that must mean that B union C is simply set B. Mr. Smith's favourite shirt is an element of set A. It's one of his clothes collection. Right. Opposite is x. Adjacent is 9. Opposite over adjacent is the tangent of the angle. That means that x is 9 lots of tan 36, which to three significant figures I get to be 6.54. If you don't get that, just check the calculator set to degrees. Calculate the value of y, giving your answer to three significant figures. Well, it's no angles, so we can't use trigonometry. It's Pythagoras' theorem. Y squared is 10 squared, take away 4.5 squared. 79.75 at this point. Then y is the square root of that. Don't round at this point, wait until your final answer. 8.93. Three positive whole numbers are all different. They have a median of 5 and a mean of 4. If the total divided by 3, because there's 3 of them, total divided by 3 equals 4, that must mean the total is 12. It's a median of 5, so we've got x, we've got 5, and we've got y. So that must mean, because they've got to add up to 12, then x plus y has got to add up to 7. They're all different, and they're whole numbers, so x could be 1, for example. We've got the 5, and then the other one would have to be 6. Part B. 4 whole numbers which have a mode of 5 and a median of 6. So there's 4 numbers, x, y, z and w, a mode of 5 and a median of 6. So we could have 5, 5, 7 and anything else really, 8. The median is 6, so it's got to be halfway between these middle two. So there we go, 5, 5, 7 and 8. Alright, or 5, 5, 7 and anything else. Similar triangles are all about scale factors. So we have to look at these two triangles, look at which sides correspond to each other, and well, it says here, doesn't it, LM corresponds to PQ, so that means that 15 is getting enlarged to 21. So what's the scale factor? 21 divided by 15 tells me that the scale factor is 1.4. So if we're talking about lengths, all of the lengths here are 1.4 times bigger than those, or 40% bigger. So x, we're going to the smaller one, so it's 14 over 1.4, which equals 10 centimeters. The value of y, we're scaling it up this time, so it's 18 multiplied by 1.4, 25.2. Watch out for trick questions where it asks you about angles. Angles don't change when you enlarge a shape. Other questions might ask you about areas. Well, areas, if you think about changing squared units, 1 meter is 100 centimeters, but 1 meter squared is 100 squared centimeters squared, or 10,000 centimeters squared. So when it talks about areas, you square the length scale factor, but that is a topic that we deal with after your mock. Right, the median length. Median is halfway, 40 tree branches, so I'm going to go across halfway. Can't really see that, can you? And read down. That looks to me like 15. An estimate for the median length, 15 centimetres. An estimate for the interquartile range of the lengths. Well, interquartile range, I need to find Q1, which is the lower quartile, 25% of the way across, which on here looks like about there, which is 6. Q3, the upper quartile, 75% of the way across, which is 30 people, or 30 branches. Read where that corresponds to, that's 35. So the interquartile range, which is 35 minus 6, 29 centimetres. Find an estimate for the number of branches with lengths of more than 44 centimetres. So I'm reading up here. 44 corresponds to that point there. That's 36, but note it wants more than 44, so it's going to be 4 branches. Solve the simultaneous equations. Before you dive into these, always look to see which scaling is going to give you the least work. So if I number them, and this pad behaves, then if I treble that top one, I'm going to get 6x take away 15y equals 39. If I leave the bottom one alone, then the thing I want to eliminate, it's positive in each case, so if I subtract, and I'm not really bothered which way around, but if I subtract the top one from the bottom one, I'm going to get 3y minus 15y, which is 18y. Remember, I have to subtract the right hand side in the same order. 3 take away 39 is minus 36. So that leads me to y being minus 2. If I now substitute that into equation 2 for no particular reason, remember it's got to work in both. 6x add 3y means take away 6 equals 3. So 6x equals 9. X equals 9 over 6, 3 over 2, 1.5. Check it in the top one. 2 lots of 1.5 is 3. Take away 5 times minus 2 is 10, positive 10. 3 plus 10, 13. Factorising. X squared, take away 8x, add 15. Pair of brackets, quadratics, pair of brackets. I'm looking for two numbers that multiply to make positive 15, add up to minus 8. If they add up to a negative, but they make a positive when you multiply, they must both be negative. Means it can only be those two. B, x squared minus 49. Special case with a quadratic, it's the difference of two squares. Same x in each bracket, same number in each bracket except for the sign change. Alright then. Quadratic again, but this time on a graph. Use the graph to solve the equation x squared, take away 4x, add 3 equals 2. Well, we've got the graph of y equals x squared, take away 4x, add 3. So what it's saying is, where on the graph does y equal 2? So we look at 2, find where it crosses the curve there and there. So the values of x we're looking for is about 0.3 and 3.5, 3.6, 3.7. Give or take the accuracy of the graph. By drawing a suitable straight line on the diagram, solve the equation x squared, take away 4x plus 3, which is the equation of the line, the curve, equals x plus 1. So again, remembering that y equals x squared minus 4x plus 3 equals y, equals the curve, is the curve. What we have to add on to it is the line y equals x add 1, which goes through there. It goes through 1, 2, it goes through 2, 3, and that's enough points. So let's try and line it up. And we're finding where the line equals the curve. So in other words, this point here, and it's about 0.4 or 0.45. And it meets it again up here at 4.1, 2, 3, 4.6. A hemisphere being half a sphere, and we want the total volume of the solid. Well, the cylinder is a prism, so it's the area of the end face, which is circular, times by the height, pi r squared times height. The hemisphere might not necessarily have been anything you've studied, the volume of a sphere, but it is one of the formulas given at the front, and you have met how to substitute numbers into formulas. Well, for a sphere it's 4/3 of pi r cubed. This is half as much, so this is 2/3 pi times radius cubed, and because it sits exactly on the cylinder, its radius must be the same. Working both of those out separately, well, if I just call that 9 pi, because that's what my calculator gives me straight away, and yours probably does the same, I'm not going to press the S to D button first. Let me just do this, and that's 9/4 pi. I'm going to add those together, so what I get is that's 45/4 pi. I'm only doing it like that because that is exact. What you mustn't do is round each of these before you add them together and then round again. Whether you put that step in or not is entirely up to you. What we should get as an answer to 3 significant figures is 35.3. And it's a volume, so it needs to be centimetres cubed. 16 we'll leave for the time being. It is something you're coming to, but just not at the minute. For those of you that are interested, it's a branch of maths called differentiation, which is part of a broader topic called calculus. Throwing a dice is throwing it 3 times. Work out the probability that the sum of the scores is 3. Well, if it's being thrown 3 times, the only way that can be is probability of a 1 and probability of a 1 and probability of a 1. Throwing a 1 is 1/6 times 1/6 times 1/6. Leave it in fraction form, 1/2 1/6. There's no other combination of throws, if you're doing it 3 times, that's going to give you a score of 3. Work out the probability that the dice shows a score of 1 on exactly 1 of the 3 throws. So that's probability of a 1 and probability of something else and probability of something else, or those 3 options in a different order. with the second one being the 1, or the third throw being a 1. So it's actually those three numbers, 1/6 multiplied by 5/6 multiplied by 5/6. That's the probability of it being in this particular configuration, but that could be the second throw, or it could be the third throw. So it's 3 times those. All you're doing in each separate case is swapping where the 1/6 is in the multiplication. So that's going to give us 75 over 2/1/6. Divisible by 3 gives us 25 over 72. Making x the subject of the equation, always a little trickier when x occurs in more than one place. But as we said earlier, whenever you've got an expression or an equation or a formula that has a fractional term in it, first thing to do is scale it up. So if I multiply both sides by x, I'll get px equals 100 lots of y take away x. If I then remove the brackets on the right hand side, my aim is to get everything involving x together. And at the minute there's a bit over here and there's a bit in the bracket as well. So now I can see the terms that involve x and the terms that don't. If I add 100x to get it over this side, I've now got all the terms involving x over to one side of the equation. I now need to isolate it and force it into one place because it's still in 2 there. But because it's the common factor, I then factorise that left hand side. Now, because I've isolated the x, I can divide both sides by p plus 100. Which means that x will equal 100y over p plus 100. These always follow the same sort of routine. X occurs in more than one place, and that's the thing you have to make the subject. Then what you have to do is collect the terms involving x and factorise. This particular question you're not able to do at the moment because we don't know enough about it and it's not a right angled triangle. Right, we have to write a 16th as a power of 2. So first of all, 1/16 I could rewrite as 16 to the power of minus 1. The next thing I need to do is express the 16 as a power of 2 and then raise it to power of minus 1. So 16 is 2 to the 4. Work it out yourself. 2 times 2 is 4, times 2 is 8, times 2 is 16. So we've got 2 to the 4 to the power of minus 1. And remember, x to the a raised to the b is the same as x to the ab. You multiply the powers when it's one expression with a power raised to a second power. So that is 2 to the minus 4. b, we've got to write 2 as a power of 8. Well, 2 cubed would equal 8, but we want it expressed in the reverse. Well, what's the reverse of cubing? It's the cube root. So 2 is equal to the cube root of 8, but it wants it as a power of 8, not as a root. Well, remember the cube root is power of a third, so that's 8 to the 1/3. Hope you found that useful. Come back soon. Thanks a lot. Bye.